Okay, let's talk about fluid power. Let's begin by just defining what fluid power is. It's the use of a fluid, either a liquid or a gas, to transmit power from one location to another. Hydraulics is when a liquid is used. Hydro, think of water. But generally we don't use water. Generally we use some form of light oil. But it's when a liquid is used to transmit power. Pneumatics, when a gas is used to transmit power. And in pneumatics, generally it's just compressed air, although I have seen nitrogen used in the past as well. Some of the benefits of these two. So hydraulics. One of the nice things about hydraulics is because a liquid is non-compressible, we are compressing it. We're putting it under pressure, okay? So we might be putting this under 500 psi. This liquid under 500 psi, but it's not compressible, which means that it's fairly efficient in transferring that power. There is heat loss and there are some losses, but we're able to take a really big motor and put it someplace else and use just like a hydraulic ram to lift something or to move something. And it's really fairly efficient. And this is the way you see most lifting and large equipment. That's how most of it works with the liquid. Pneumatics. The benefit of pneumatics is that I can store the gas. I can put the gas in a tank and I can compress it up, and then when I have a large consumption rate, I can take that out of the tank and the pressure in the tank will drop and the compressor will bring that up. That's one of the big advantages of pneumatics. The other big advantage to pneumatics is I don't really have to have a return line. So in hydraulics, if I have a hydraulic ram over here, boy, that's not a very good ram. Pushing out here, let's try that again. So I've got a ram here, and this ram goes down and there's a piston inside of here. And I'll put oil on both sides, so I'll have an in and out. And when the piston's going down, we're drawing oil out of this and we're pumping oil in here. When the piston goes up, we're pushing oil in and we're pulling oil out. And we can do the exact same thing with pneumatics with air, where a lot of times with pneumatics we might have a spring in there and we only pressurize it, and then when we're done with it, we just allow that air to go right to the atmosphere. We don't worry about returning it. On a hydraulic, if I have a pump here, I have to return that back to the pump. I can't just spew that oil out into the atmosphere. It'll get all over everything and people will be falling down and slipping, and what, I mean, it's expensive. So with hydraulics, I always have to have a return line. With pneumatics, I don't. I can just, especially if I'm using compressed air, I just go ahead and release that air back to the atmosphere, and the return line is the atmosphere, because then I'm going to just compress air later and that air will cycle. Again, the non-compressibility of the liquid makes hydraulics very reliable and very predictable on how it's going to function. With pneumatics, because a gas is compressible, as I fill this cylinder with gas, the friction and the resistance is going to keep that piston from moving because that gas can compress. Then all of a sudden, this might jump 4 inches. And then it'll stop again because the friction is taken over. And I have to build that in. So with a pneumatic system, you will often see little jumps as it opens. One of the main places that we use pneumatics in production lines, and that it works really well on, is as gates, opening and closing gates. Because I can apply a fairly large force or high pressure, which will swing that gate really quickly. And so I can move things really quickly. The nice thing about a gas is that as I pump air in here, I can pump a whole lot in really fast. Whereas the liquid, being a little bit thicker and a little bit denser, um, it has it doesn't flow in as quickly. It has a more friction and resistance on it flowing into my cylinder. So those are the main advantages and disadvantages for fluid power.